Okay, let us start the next problem. Consider the following table of arrival time and burst time for three processes P0, P1 and P2. So there are these three processes P0 and P1 and P2, and their arrival times are different, 0, 1 and 2, and the burst time, the CPU time they need, is 9, 4 and 9. And then what is given is that you have to consider preemptive shortest job first scheduling algorithm. Okay, scheduling is carried out only at arrival or completion of processes. That is fine. What is the average waiting time for these processes? So you have to find the average waiting time for this process. Means after they arrive, how long they spend waiting. Okay, that's what you have to find. So what I'm going to do is, first I'm going to write the initial bursts out here, 9, 4 and 9. I write them because they change, and out here I'm going to mark their arrival times. Okay, so 0, and this is where P0 arrives. Okay, and then there is 1, and this is where P1 arrives, and this is 2 out here. Okay, and this is where P2 arrives. Okay, so this is all I have for now, and it's shortest job first. Okay, and it's preemptive, so if it's basically shortest remaining time only. Okay, it's just given different name, it's shortest remaining time. So let's start. So when P0 comes, that's the only process, so that means that the first process to run must be P0, and at 1, okay, after 1 seconds P1 comes. Okay, so after 1 seconds the bursts left for P0 are 8, and P1 comes, and for P1 it needs only 4 bursts. Okay, and the left are 8, so that means P0 will be preempted, it will be kicked out by P1, and the CPU will be given to P1 from here, like this. Okay, so this will happen, and then at this time 2, P2 comes. Okay, by then P1 will be 3, but P2 is 9. Okay, so P2 is not going to kick P1 out, and P1 will continue and finish its bursts. Okay, and so that means from 1 it will continue to 5 because it needs 4 bursts. Okay, so it will continue up till here, so P0, P1. Okay, and then this is done, we are done with P1, we are left with P0 and P2. So out of these two, P0 has smaller bursts, it needs smaller bursts right now because it has already completed 1 burst before, it needs only 8 bursts. So that means that CPU will be given to P0, and it will go ahead and finish 8 bursts, that means up till 13. Okay, and then P2 will come and finish all the bursts up till 22. So this is what is going to be going on in this thing. And then if you want to find the average waiting time, you want to find the average waiting time. Okay, so what do you know about the average waiting time? The average waiting time is the waiting times, you take the average of all the waiting times. Okay, so P0, so how much is P0 waiting? So P0 came here, it didn't wait, and it was waiting from 1 to 5. Okay, and then it got finished, so it waited for 4 time units. Okay, you can see it out here, it waited for 4 time units. Okay, that is P0. What about P1? P1 came here and it got done, so P1 did not wait at all, so 0. Okay, what about P2? P2 came here and it got the CPU out here, so it came at 2, it got the CPU at 13, so 13 minus 2 is 11, and that's the waiting time. So this divided by 3 is 15 divided by 3, and that is 5. Okay, and that is the correct choice.